Okay, so this is the last one of section 1.5, and it is the quadratic formula. Like I said, last but not least, it's quadratic formula, and it can always, once again, always be used to solve quadratic equations. Okay, so there's no restrictions on this one either. Our steps for this is to write in standard form. And standard form is a x squared plus bx plus c equals 0. Okay? Then our next step is we're going to identify a, b, and c, which are the coefficients in front of your variables. Does not include your variable. Then we are going to substitute these into our quadratic formula. Kind of just plug and chug is what I like to call it, because we're going to plug it in to our quadratic formula and then just chug along until we find the answer, and then we just simply simplify. Okay? Now we need to talk about the radicand, and the radicand is what is underneath the square root. So the radicand is what is under here. This is our square root, and this, I'm going to do this in a different color so it stands out. This is our quadratic formula, okay? And then right here, sorry, wrong pen. Right here is our radicand, okay? This is our radicand. So the radicand is the b squared minus 4a times c. It is also called the discriminant, and it determines the type of solution that we will have for the quadratic. So when our b squared minus 4ac is greater than 0, this means positive. Then we'll have two real solutions, two real answers, okay? And what that's going to look like when we graph it, cross our x-axis twice. So it would look like this, okay? Then when our b squared minus 4ac is equal to 0, then we'll have one repeating real number. The solution. And what that's going to look like when we graph it, have one point here that touches the x-axis, and then it's going to go from here. That's what it would look like graphed. And then here, when b squared minus 4ac is less than 0, which means negative, then we're going to have two imaginary numbers. And what that would look like when it's graphed. It's not going to touch the x-axis at all because it is imaginary, so it would be something like this. Right? There'd be no x-intercepts whatsoever. So like I said, here is our quadratic formula. And then here's the standard form, which I wrote again up here for you. Here's an example. If we have 2x squared minus 3x plus 1, so our a would equal the 2, which is the coefficient in front of the x squared. Our b would equal negative 6 because it's the coefficient in front of the x. And c would equal 1 because that is our constant, okay? Then we would just simply take these and plug it into, like where our negative b would be in place of this b. And then it would be also in place of this b. And always put this in parentheses so that the negative is also squared, because that will definitely matter in your answer. And then your c, well, it's 1, so it would go here. And then we just keep working until we get our solution. Okay. So let's do a few. So the first step is it in standard form. What is? Because there's a polynomial equals 0, so we're in standard form, yes. So our second step is to identify A, B, and C. So our A, if we look over here, equals 2. Equals -6. And C, okay? So now we plug these into our quadratic. Okay, we're just going to plug and chug, so that's what we're going to do here. This is kind of our step 3. I probably should have changed colors on that, but let's do it. We can do it all in the same color, I think. So our quadratic, I'm going to write it up here on the top so that you have it. X equals -b plus minus the square root b squared minus 4 times a times c. All this is over 2 times a, okay? So let's do that. X equals, remember it's a -b, so negative, and our b is already a negative, so we'll put that in parentheses. Ooh, that's a 6. Almost wrote b. So square root of -6 squared minus 4 times 2 times 1, because that was our a and our c. All that's under a square root. All this is over 2 times a, which is 2. Okay? Now our next step is always to simplify our quadratic as we go along. So let's do that. I'm just going to draw an equals over here. And a -6 becomes a +6. -6 squared gives us a 36. So this is going to be square root of 36 minus 4 times, -4 times 2 is a -8 times 1. So it's -8. All this is over 4. Once again, 6 plus minus the square root, 36, minus 8 is 28 over 4. Okay, so now we have to simplify our square root of 28. Let's step over here. Square root of 28. We need to make this be into an even square. So 28 is the same thing as saying 4 times 7, right? So what's the square root? We could break this into 2. Square root of 4 times the square root of 7. And it's easier to see that way, and that is completely legal in math to separate those two. So the square root of 4 equals 2, and this goes no farther without being like a decimal. So we're going to say square root of 7. Okay, so that is what the square root of 28 equals. So we're going to simplify that to be this. So now we're going to have x equals 6 plus minus, and we're going to write square root of 28 is this. 2 square roots of 7 all over 4. Now we can look and see that 6, 2, and 4 are all even numbers, so we know that they're divisible by 2. So let's do that, okay? So 2 goes into 6 3 times. 2 goes into 2 1 time, and 2 goes into 4 2 times. So let's rewrite that simplified, okay? So this is going to be 3 plus minus. 1 times square root of 7 is just square root of 7. So we do not need to write the 1. And this is going to be over 2. So this is our answer completely simplified, which is what we always want to write our answer as in algebra. If you don't write your answer all the way simplified, you will miss at least 1 point, okay? And we work really hard to get our answer, so we don't want to miss any points. So now our x, we want to write it as 2 answers because it is 2. We have a plus and a minus. So x equals 3 minus square root of 7 over 2, and 3 plus square root of 7 over 2. So that would be our answers. Okay. If you were to graph this on your calculator, do that real quick. If you do y equals 2 squared minus 6x, sorry about that, 6x plus 1 and then if we graphed it, that our radicand was a positive, and when we did the thing before, we saw that it would have two intercepts on our x-axis, and that is exactly what we had, because those are two real numbers, so that's what we got. So that's what we expected to get, so perfect. All right, let's look at this one. Same steps as above, so I'm not going to go through them. It is in standard form because we have polynomial equals 0, so that's great. Now we could jump to the second one, which is identify A, B, and C. What does my A equal? 3. B equals what? Next, right on. And C equals 4. Great job. Now we just plug and chug, so let's do that. So my x equals negative 2, right? Because this is already negative. And we look up here and we see it's a negative b. Okay. So then plus minus square root, parenthesis, negative 2 squared minus 4 times 3 times 4. All under your square root. And then 2 times a, and a is 3. Now, I'm going to go ahead and go this way, and we're going to simplify this one, which is going to be a positive 2 plus minus square root. Negative 2 squared gives us a 4. Take negative 4 times 3, that gives us 12, times 4, that gives us a negative 48. And all this is over 6. So now let's do the math on our radicand. X equals 2 plus minus square root 4 minus negative 48 is going to give us a negative 44 all over 6. Let's jump over here and simplify our radicand again. We have a negative 44. We have a negative underneath. We could automatically pull him out, and that's going to be an I square root of 44. Remember, a negative 1 equals I when it's under a radicand. So now we have I times the square root of 4 times 11, right? Because 4 is an even square. So I times the square root of 4. Square root of 4 is what? 2 times I square root of 11. So that's going to be simplified form of square root of negative 11. So we'll rewrite that as this. So 2 plus minus 2i square roots of 11 over 6. Now once again, we can see that 2, 2, and 6 are all divisible by 2. So let's do that cancellation. 2 goes into 2 one time, and 3 times. So let's rewrite this. We have to write this one, so 1 plus minus, but we don't have to write this one because 1 times I is just simply I, square root of 11 over 3. Now we have x. We're going to write this as 2 because we have two answers here. 1 minus I square root 11 over 3, and 1 plus I square root 11 over 3. Okay, so now since our radicand was negative, we're going to expect when we graph this for us not to have any x-intercepts, right? It's not going to cross the x-axis. So let's see what happens when we graph this. You see it? Okay. So we have 3x squared minus 2x plus 4. And let's graph it. Graphs up here, so we don't have any x-intercepts, so that's exactly what we needed to see. So we're happy. All right. Next one. Once again, it is already in standard form because we have a polynomial equals 0. So let's just go ahead and identify A, B, and C. What does A equal? Applied 1 here, so A equals 1. Equals -2, and C equals 2. So we'll just plug and chug once again. So X equals -2, because it's a negative B, and this was already negative, plus minus square root of -2 squared minus 4 times A times C, all under the square root, over 2 times 1. So now let's simplify. -2 is a positive 2, plus minus -2 squared is going to be the square root of 4 minus 8. Equals 2 plus minus the square root of -4, 2. Once again, we have a negative radicand, so we're going to expect to have no x-intercepts, right? Okay. Step over here, simplify -4. We're going to pull that I out right away and then have square root of 4. Square root of 4 is always 2, so that's going to be 2i. Rewrite this as 2 plus minus 2i over 2. And we can easily see that all of these are divisible by 2. So we'll have 1, 1, and 1. And we never write the 1 on the bottom, right? That's just always implied. So we're going to have this equals 1 plus I. Ooh, plus minus. I am so sorry. Can't forget that little minus there. Okay, so our x is going to equal 1 minus I and 1 plus I. So that'll be our two answers. And then if we graph this real quick, so we can see it. X squared minus 2x plus 2. See that we have absolutely no x-intercepts whatsoever, so it is what we were expecting. Okay, right on. All right, so this one is a little bit different. It is already in standard form, so we could just go straight to the plug and chug. So A equals 9, B equals -6, and C equals 1. So x equals -6 plus minus the square root of -6 squared minus 4 times 9 times 1. And that is a 9, not an 8. Sorry, I'm working 8. All 2 times 9. That's going to equal +6 plus square root of 36 minus 36. So if we look at our discriminant, that gives us a 0, right? So that's different because it's the same. And if you remember that when the discriminant is 0, we're going to have a repeating number. So when we go ahead and solve this, we're going to have x equals 16. Wow, where did I get 16? My bad. 6 over 18, which is going to be 1/3. Because it's just 6 plus minus 0, so 6 over 18. And our answer would be 1/3. Answer for this one. Okay? Well, that's the end of 1.5. So, now you guys, I feel like, are ready to tackle your homework. Have a great day.